In this video, I'm going to be talking about vectors. Vector! Yeah! So what a vector is essentially just something with a direction and a magnitude. So I'm going to draw something else on here. I'm sorry. I'm sorry. I'm so sorry. That right there is called your direction angle. Yeah, wrote that very well. Oh, sorry. Is your direction angle. So essentially, something with a magnitude. Magnitude is just your length or your strength. So like if I throw something in this direction, say I'm standing here, and I throw something at that angle, if I were to throw it harder, the vector would be a little bit longer because it would have more strength. If I were to toss it lightly, the vector would be shorter because I would be giving it less strength. So depending on how big the vector is, depends on how much force is applied in that direction. There are two ways of stating vectors. One is called component form. This is like a greater than or less than symbol or something like that. It has the x direction and the y direction of the forces. Same idea with the standard form, x direction and y direction with the forces. I is essentially 1, 0. J is essentially 0, 1. So it's just the force applied in the x direction and the force applied in the y direction. That's all those vectors stand for, but we do expect to see I and j written in standard form. Another thing to note, that this is the magnitude. This is how you write the magnitude. So the magnitude of this vector v is just the length of the vector. It looks like kind of like two absolute value symbols around that v. It's not like an 11 or something like that. So when I write it, it's absolute value symbol, and there's just two of them around whatever vector we are talking about. All right, so looking at the first question, graph each vector in standard position. So what standard position is essentially, just like we saw in our beginning, notice I am starting from the origin, which is 0, 0, and I'm going to the point where my vector is. So 2, 3 would be over 1, 2, up 1, 2, 3. So I usually put like a point there so I know where I'm going to. And then I start from my origin and I go to the point and stop. And then I draw an arrow in that direction. So now it also says find the magnitude of this vector. Well, in order to find the magnitude, if you make this a triangle, like we were doing for the past two chapters, this is over 2, up 3. So to find the magnitude, it's just the length of the vector. So the length of this vector, you can just do Pythagorean theorem. So you have 4 plus 9 is 13. Take the square root of that, and that is the magnitude of your vector. Happy day. Looking at another. This is in standard form. Yes, standard form. So I'll graph it where it is, over 3, up 6. So over 3, up 6 is somewhere about right there. So that I knew I went over 3, up 6. So to find the magnitude, 3 squared is 9, plus 6 is 45. So I have the square root of 45. Happy day. Same idea, except now, I have negative 6, negative 2. So I will go negative 6, so negative 6, negative 2, going to that point. So now it's just going in a different direction. But still, we find the magnitude the same way. 6 and 2. The magnitude of this vector v is 36 plus 4, square root of 40. All right, same idea, over 4 down 2 now. So over 4 down 2 would put us in the fourth quadrant. So over 4 down 2, something like that. Notice I have arrows on the ends of all of these, such that I went 4 down 2. The magnitude of this vector v would be square root of 20. Okay, that's essentially all that vectors are. Again, they have a direction and a magnitude. The magnitude is just the length, so you can use Pythagorean theorem to find that. All right. So now another thing to note is that vectors don't have to always start at the origin. They can be anywhere. So I can throw a ball or something with the same force above my head as I can below my head. So like if I tossed it underhand with the same force and same direction as I threw it overhand with the same force and direction. So here's like me. I can't show you me right now, Well, I can. Hi, that's me. Ah! Right, that's me, but it's too dark.
It's too dark. I need it bright in here. I can't see you.
Sorry. Man, throwing. So he throws ball from there. He can also throw ball from there. It can have the same direction and the same magnitude, but go from a different position. So we have determine component in standard form for each vector in space. It's out in the outers. Whatever I'm saying, I don't know. But essentially, vectors, you just have to remember they have an x direction for their force and a y direction for their force. So from -2 to +4, this went over 6. From -1 to +1, this went up 2. So this vector is 6, 2. The x direction of the force and the y direction of the force. In standard form, this is 6i plus 2j.
Oh, it's so pretty.
Cool. Yes. So notice initial and terminal point. It was going from this point to that point. If it were going the opposite way, these numbers would both become negative. So it matters which direction they are going. Here we have an initial of -3, -4. So if you want to graph this to help you understand, no problem. I do it too. And then a terminal is 6, -12. So over 6, -12. So it looks like this vector should be going down. So we should have a negative y with it. So now just looking at the numbers, from -3 to 6, that goes up 9. From -4 to -12, it goes down 8. So I have the vector -9, -8. Or sorry, 9, -8, 9, -8. No, 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 no. So then I have 9i minus 8j, and that would be our vector in standard form.
Beautiful. Oh, so pretty. I like it. I like it a lot.
I promise they'll institute me someday, and you guys won't have to deal with me anymore. All right, so now we have determine the words. I can't talk today. Determine the direction angle of each vector. So this is the direction angle as it relates to your unit circle. So the vector 2, 1 over 2 up 1 will be right here, and the direction angle is the angle from 0 counterclockwise around your unit circle. So in order to find that, I probably need that off. All right, there we go. If I do a triangle, this went over 2 and up 1. Well, I have the opposite and the adjacent side, so I can use tangent from that angle is opposite over adjacent. I can figure out that the angle is, gosh, I think it's 26 point something. I don't remember. Give me a minute. I'm sorry. I'm trying to type it in my calculator. I don't know. Yeah, it's 26.57. 26.57 degrees. All right. There's nothing really more to do there because that is starting from 0 degrees and it's going to 26.57 degrees. So that is our direction. Get out of the way. All right, so here I have -3, -2. So this is in a different quadrant, but still, so -3, 1, 2, 3, -2, vector, vector. My direction angle needs to go from 0 degrees around to the vector. So now when we draw our triangle, we're still going to use it to help us figure out what that angle is, but I'm going to have to add 180 to it since I'm starting from 0 plus this 180 right there. That's 180 degrees plus this little angle inside, whatever we determine that to be. So I know I went over 3, down 2. Again, I can use tangent. I'm going to call that one alpha so I don't confuse it with the direction angle. So tangent of alpha is opposite over adjacent. So I have tangent inverse of 2 over 3. Don't forget to use inverse whenever you are determining angles. It's probably a good idea. So I have 33.69 degrees. And since that is not my direction angle, because that's only going from right there to right there, I need to add 180 to that such that my direction angle is actually 213.69 degrees. There's my direction angle. And if you think about it, on the unit circle, 213.69 degrees puts you in the third quadrant. Hey-oh, magic tricks. All right, I'm going to do a couple more of these just to make sure you guys are golden. Beautiful. Oh, yes. So I have -4, +6. I can't. Words are not being my friend today. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Chicka-pa-chow.
Shabadoo!
So that is my direction angle. So if I find that little angle in there, I know both of those angles have to add up to be 180 because they're on a straight line. So I have 4, I have 6, I have tangent from my angle inside is opposite over adjacent. So when I type that in my calculator, 6 and 4 tangent inverse, that gives me 56.31 degrees. 56.31 degrees is that alpha inside. So to find my actual direction angle, remember from the unit circle, starts from 0 degrees, goes around counterclockwise to it. So 180 minus that should be 23.69 degrees. That is our direction angle. And again, if you think about that, that puts you in the second quadrant. Yeah, that fell. Oh, I like it. 8, -2 will be in our fourth quadrant. So over 8 down 2. So that would be our vector right there. And again, the direction angle is going to go all the way around to your vector. So we are this angle short of 360 degrees. So if I draw my triangle over 8 down 2, I can do tangent inverse of 2 over 8. So tangent inverse of essentially 1 over 4, 14.04 degrees. So if I do 360 minus that, that means my direction angle has to be 345.96 degrees.
Oh, happy day!
We're almost there. We're almost there. Getting close. Getting close. Doing good.
Doing good.
Determine component form of each vector with the given characteristics. So notice, I am given the magnitude and the direction angle. So if I have a direction angle of 200 degrees, I know, because I know my unit circle, that that would put me in the third quadrant by just a little bit. So my vector's there with magnitude of 8, and I know that that is 200 degrees right there. So since that's 200 degrees, that must be 20 degrees right there. If I draw my triangle, because component form is x comma y, so I want to know how far I went in the x direction and how far I'm going in the y direction, so x direction, y direction. Well, in order to do that, we can just use right triangle trig again, because that's a right angle right there. So in order to find the x, I can say cosine of 20 degrees is adjacent over hypotenuse, and to find the y, I have sine of 20 degrees is opposite over hypotenuse. Multiply by 8 in both of them. So we have 8 cosine 20 and 8 sine 20. And I'll enter that in my calculator. Oh, well, I guess I don't have to. What's wrong with me? I don't know. All right, so we figured out this is 7.52 and this is 2.74, but we have to think about it. It's going to the left and it's going down. So when I write this in component form, make sure we have negative 7.52 and negative 2.74, such that it is going negative direction in both your x and your y direction. All right, we're going to do the same thing. One more of these. One more of these. All right, so again, magnitude is 16. 100 degrees is in my second quadrant. Something-ish like that. I know this is 16 units. And if this is 10 degrees, then this is 80 degrees. And I can draw my triangle to figure out how far in the x and y direction we went. So again, cosine of 80 degrees is x over 16. Sine of 80 degrees is y over 16. So one more time. Enter in my calculator. Yes. Colonel Sanders. Eat some fried chicken, Colonel Sanders. I don't know. I'm sorry. I'm stupid. 2.78, 15.7 7, 6. So again, here I'm going left in the x direction, so my x value will be negative. But I'm going up in the y direction, so my y direction will be positive. And C. All right, just a bit more. We're getting so close. This is it. After this, when we do that, we'll be done. You guys are doing awesome. I'm sorry. I'm trying to make sure I explain things thoroughly to you guys. All right, so now, what we're going to be talking about is when we are combining forces of vectors. So like something is pulling in different directions. So I'm taking vectors and I'm adding to them, I'm subtracting them, such that I can find a combined force. So we are given three vectors. We're given v, w, and t. The first one, it wants us to take v and add 2w to it. So I know v is the vector 2, negative 1, plus 2 times what vector w is, which is negative 6, 4. So now, I need to double the vector w. So when I double it, I need to double both x and y direction, such that this becomes negative 12 and 8. And I didn't do anything to v, so it stays the same. And when I combine these, they have a total combined x direction and a total combined y direction. So when I have 2 and negative 12, together those make negative 10 in the x direction. And in the y direction, I have negative 1 and 8, which together will make a y direction of 7. That would be it. That is v plus 2w. So again, same idea. 2 times t minus 3 times v. Well, 2 times what t is, so 8 negative 2, minus 3 times what v is, which is 2 negative 1. Am I off the screen? No, look at that. I was so close. Yes, perfect. Perfect! Ah! So again, I'm going to distribute the numbers in front, so 2 times 8, 2 times negative 2, and then negative 3 times 2, and negative 3 times negative 1. You don't have to distribute the negative with it. I like to because it will make this positive, so then I'm just adding the x's and adding the y's like we did in the last one. You'll kind of see how that works. I don't want to talk to you right now. Don't text me. So I have 16 and negative 4 plus negative 6 and 3. And then again, it's just the total combined x direction, which will be 10. Total combined y direction, which is negative 1. There is my vector.
Vector! Yay! I like vectors. They're super fun!
I don't know. Don't ask. I just had some caffeine, so you can see. Down, look, there's the can. Oh, it's not very focused. But there's still some caffeine left in there. This watermelon energy drink, 240 milligrams of caffeine. I need to stop drinking these things. I'm going to give myself a heart attack. Especially as you get older, Pike. Take care of yourself. Crazy kid. Old Pike's going to go back and watch these videos and be mad at young Pike for not taking care of himself. What's wrong with you? Why did you do this to me? Dogs are freaking out. No, they're not. They're sleeping on the couch. I thought Cora was mad. Okay. All right. So this was 2 times t plus 6 times v minus 4 times w. So all I'm going to do here is just distribute, and distribute. Oh, yes. I think I said distribute 4 times, but I don't know. I'm sorry, I should have turned the video off when I was doing all that. All right, so we have 16, negative 4 when I distribute the 2, 12, negative 6 when I distribute the 6, and I'm distributing the negative 4 into both of those to get that vector. So now, last thing, combined x direction. So combined, they have 16 plus 12 is 28, plus 24 is 52, I think. Yes. I'm going to go with that. I'm going to roll with it. If it's wrong, it's wrong. I don't think it is. I don't know. Anyways, total combined y direction. So I have negative 4, negative 6, which is negative 10, minus another 16 is negative 26 altogether. Happy day. All right, last one. Like I said, last one. We're almost done. I'm so excited to be done. Use the set of vectors to draw a vector diagram of each. So we are given I know we're not given any like units, but we're just going to kind of guesstimate. U is something like this, V is something like this, T is something like this, and M is something like that. We're going to pay attention to the direction and the magnitude, because those are really the two things that matter with these vectors. So if I have vector M, so what these are is I'm still doing the combined forces. We just don't have numbers like we did in this last one. We just have pictures. So we're going to draw a vector diagram. So essentially what these vectors would make together. And then we'll be able to see the result of all their forces. So M, start from left to right. M is something like that. So I would start and draw M about where M is. So that was M. Plus 2V, different color. So I'm going to take V and I'm going to do it twice at the end of M. So M, now I'm going to do V once. So there's V once, there's another V twice, so there's two V's. So now the result of these things, kind of the total combined force, is how far from the starting point they went in the X and Y direction. That is called our resultant vector. So I'll always just connect them from the beginning to the very, very end, wherever we end up all together. That is our result. It's the result of adding or subtracting these vectors. So now if I take vector t looks something like that. So I'll take vector t and I'll do something like that. About the same direction, about the same distance. It doesn't have to be exact. I'm not looking for like perfect, just aboutish. All right, and then we have minus v. So now minus v, what this is doing is it's going 180 degrees, the complete opposite direction. So if I have v, then negative v goes something like that. So about the same distance, but just the opposite direction. If this is t, negative t would go something like that. M and negative n, you kind of get it. So negative v now is just going the opposite direction, about the same length as v. So my resultant from the very, very beginning to the very end is my resultant vector. All right, moving on. I have 1/2 of u. So I'm going to take what u is and do 1/2 of it. So now u, 1/2 of u looks something maybe like that. Oh, you can't see it. Oh no. I'm going to zoom out. Duh. Hello, Pete. All right, we have 1/2 of u, and then I'm going to add 2m to that. So I'm going to add 2 m's. So I'm going to do m once. I'm going to do m twice. Zoom out just a little bit more. Sorry. I didn't make it big enough. And then I am going to do plus t. So plus t would do something like that. And then again, our resultant is from the very beginning to the very end, always in a straight line. Even if it goes through vectors, it doesn't matter, but it's always in a straight line. All right, last one.
We're almost done, yes!
1/4 of m. So if this is like 1/2 of m, then 1/4 of m is about that. So I'm going to do 1/4 of m plus 3 times v. So 3 v's, so I don't want to use that color, plus 3 v's. So I have v once, v twice, v 3 times, minus 2m. So I'm going to do negative 2m. So negative m would go in the opposite direction. So I have negative m once, negative m twice. Sorry that it's going through my 3v, just happened. And then from the very beginning to the very end is our resultant vector. All right, hopefully this video has been helpful for you guys. Again, sorry that it was so long. I'm just trying to be super informative and helpful, and that doesn't look like a monkey, but now it does.